Let's do 70. No. I'm just telling you guys. Okay, I know I told you guys from here all the way to 74. I think I was supposed to do 71 with you guys. You know what? That is okay. Just let me know if you guys have questions on that one, because we did review this one on the parent graphs. So go back to your parent graphs. If you need help with that one, just X that one out. Let's do 75. Okay. To expand a logarithm, when you have an argument, and in the argument you have a multiplication, you can use plus. What this means is you're going to go log, and again, this is a base of 10. You don't have to write the 10 anymore. So you can go log of 7 plus log of 11, and that is the same thing. Okay. So to expand, if you have a times, you're multiplying two different terms inside the argument. You're going to split them up with a plus and split them up individually. Log of 7 plus log of 10. It's up to you if you can write the base of 10. But really, this is, log of 11. Okay, that's it for 75. 76 is going to be similar. Let's jump down to 79. 79, I would raise the power of each of those arguments to the power of 6. And so you're going to have log base 5, x to the 6 times y to the 24th. And then now we can split them up. Log of x to the 6th base 5 plus log of y to the 24th, also base 5. Last but not least, what you can also do is take these exponents and put them up front. Okay. So your final answer is going to be 6 log base 5 of x plus 24 log base 5 of y. Let's just check our answers. I mean, sometimes, like, when you haven't done this in a long time, then 79, 6 log. Yeah, that looks all right. Yeah. Let's do another one together, 81. Okay. What I want to do is rewrite that square root into a power, and then the exponent is going to be a fraction. So log base 4 of u times v times w to the 1/2. Okay. And then each one can be raised to the power of 1/2. Okay. And then from there, you can split them up using addition. Log of 4. Last but not least, those 1/2s can be up front, and you are done with 81. Okay. I do want to remind you guys there are two ways to write this. You can either have the 1/2 log of u base 4, or sometimes on the answer key they just put that all over 2. Okay. It is the same thing. Same thing. Okay. So I'll just go back to the 1/2. Same thing. Actually, I am kind of curious as to how the answer key does it. Let's check 81. Yeah, actually, the answer key does it the second way, where they put the 2 on the bottom. It's the same thing. Okay, so we'll accept both written ways. 87. Okay, 87. Well, let's go raise each of these terms inside the argument to the power of 5. So it's going to be log 12 to the 5th power. How did I forget 6 times 5? 6 times 5 is 30. No, it's not 35. 30. Gosh. I don't know. Sometimes, should I even be teaching calculus? Okay, anyway. After you are done with that, this is a division. To expand, when your argument has division, you're not going to do addition. You are going to do subtraction. So it's going to be log of 12 to the 5th power minus log 7 to the 30th power. Okay. The purpose of this is to just expand, and so you're not going to actually do 12 to the 5th power, nor 7 to the 30th power, nor I don't want you, nor do I want you to do that. So just take the 5 and take the 30, and you should be done. 5 log of 12 minus 30 log of 7. That should be it. Let's check that answer key, 87. Yeah, okay. Okay, and then that's that. Okay, 93. This time around, 93's instructions is to condense each expression to a single one logarithm. And I'm just going to go backwards. I mean, that 6 can be put over there. I think that's all we can do. That's all we can do. Let's check. Yeah, that's all we can do. Okay. Let's move on to the next. 99. Okay, 99. We got plus, and then we got that 4 over here. So maybe that 4, we can probably put it as an exponent first. And so let's go log of a base 4 plus log of b base 4 plus log of c to the 4th power base 4. Now that they all have the same base, the same logarithms, I think we can just condense it by multiplication. So it's going to be log base 4, a times b times c to the 4th power. That's really all we can do really for number 99. Let's just check that. Sometimes I just want to check. I mean, they have it in different order, but it's the same thing. Okay. 101. Okay. 101. Let's see. Well, I think I want to put the 5 and the 3 respectively in their respective exponential placements. So log of z base 4 plus log of x to the 5th power base 4 minus log y to the 3rd power. Okay, we have a combo now. We have a combination. So we're probably going to have one multiplication and one division. They all have the same logs. So this is one way we can write it as one log. So we can go z times x to the 5th, and then the y to the 3rd will be your division, will be in the bottom of the denominator. This is just going to be one way, so now we've written it as one log. Let's just check, yeah. Yeah. And then I don't think you need the multiplication sign afterwards, but we'll accept this one. Okay. So that is 101. How much more do I have to do until to the next? I think I can do 105, 106. Okay, yeah. Let me do 105, 106, and then that might be it. And then I'll move on to the next video. Okay, so 105. Solve each equation. Use the log rules to help you solve. Condense first. Okay, I see. This left side, I think we can condense first because they already have the same logs, and then we can put the arguments together. We can change this into one log. So let's condense. Log base 8, and we can do 5x times 2 is equal to 1. Okay. So instead of 2 additions, we'll just do 1 multiplication with 1 base. Really from here, now it's in log form. Change this back into exponential form. We got our base, 8. Our exponent is a 1. And then our argument, 5x times 2, which is really just 10x. Okay, almost done. Divide both sides by 10. Okay, Okay, and we're going to reduce this. X is equal to 4/5. Divide top and bottom by 2. We just have to make sure before accepting it that it's not going to make the arguments a 0 or a negative number. And I think we're safe because this is already positive, so that's okay. And then if we put 4/5 over here, 5 times 4/5 is going to be 4. So which is also, it's positive. So we're good with this. We are good. Let's do 106. Okay, good. They already have the same base. Arguments are different, but we just have a negative. This time around, we're going to condense these, but we're probably going to use division. X plus 10 is going to be on top, and then the 2 is going to be on the bottom. Okay. Now we can change this into exponential form. 6 to the second power, which is this over here, is equal to the argument x plus 10 over 2. Let's solve for x. We're just going to times 2 on both sides now to get rid of this. Okay. 2 times 6 squared is 72 because this is 36. Okay, and then we're going to just subtract 10 on both sides. X is equal to 62. Let's just check to make sure that none of the arguments are going to be negative. 62 plus 10. Oh yeah, that's totally positive, so we can accept that. And this is already a positive 2 here. So this is an accept here. Okay. I will see you guys on, I hope the last video, really. But before we move on to the last video, I think the problems that I want you guys to do, if you don't want to move on, and you want to do the problems, is up to 110. So up to 110 and then 76. So if you don't want to move on just yet and you want to do some of the problems on your own first, so 76 to 110 right now. Otherwise, then I'll see you guys on the next video, and hopefully the last one.